Hello champions, very good evening to all of you. How are you all? So this is your chemistry expert Sanjay sir, and today I have come up with the very amazing session that we were already awaiting. This session is your most expected 50 questions from chemistry for our JEE Main first attempt 2025. So everybody please gather around, jaldi se aa jaiye sabhi log. Let's have a big round of and big amazing confidence and an excitement over here for this very amazing short 50 questions from JEE Main. And I want to give you one idea over here that guys, this entire concept, it came in my mind. How did I realize that what can be those most predicted question? Everybody right now is targeting 100, 200 or even more number of questions for the preparation. So I personally think that in this entire huge year, you might have covered so many good concepts, numericals, practicing, so many things have been done. What I am giving you is an idea that what topics are pretty much very much confident about, like JEE is very much confident about those topics, and the question will definitely come up from those topics. That is what I have picked up with. Entire 23 to 24 chapters, considering all of your physical, inorganic, organic chapters in terms of, like, let it be chemical equilibrium, ionic equilibrium, counting this separately, and also practical organic chemistry, practical inorganic chemistry, adding these two chapters as well. There are, like, every chapter will be possessing on an average of 2 to 3 questions, and that's what I have come up with. Let's start our first question from mole concept. I'll also give an idea what topic do I find are very important from mole concept. I personally have a very huge confidence on stoichiometry. Always these kind of questions have been asked from like the stoichiometry term. Sometimes these questions can be difficult in terms of calculation. Sometimes these questions can be even easy. So let's see how can we solve this question. There we go. The first question is simple and says that for HNO3 KCl is giving you Cl2NOCl and H2O KNO3, the amount of HNO3 required to produce 110 gram of KNO3. So guys, what I can do is I can simply approach the mole analysis over here. Mole analysis is very simple, that the number of moles of HNO3 is required divided by its stoichiometry must be equals to the number of moles of KNO3 potassium nitrate divided by stoichiometry 3. Now you simply put the amount of HNO3 required to produce 110 gram. So this has been given to us. Its mass is 110 divided by. So we'll separately calculate out the molar masses of potassium nitrate and molar mass of HNO3. So I would like to expect all of you people to solve these questions parallelly with me, so that in any case you can ask me whatever doubt you are facing. Okay, the chat box is still open with me. I can read out all the chats what you are writing. Hi Pradeep Jain, hello. So everybody please solve it. Potassium nitrate K, the molar mass of potassium is given to us is 39, plus nitrogen has a molar mass of 14. Then we have O3, that is 30, 16 into 3 will be 48. How much does it come? I guess it's 101 gram per mole. Right, isn't it? This is your KNO3. Potassium, we are taking mass 39, 14 and 48. Okay, then we'll also calculate the molar mass of HNO3. HNO3 is also needed somewhere over there. So HNO3 molar mass will be 1 plus 14 plus 16 into 3 is 48. So this will be 15, 8, 5, 13, 1, 5 और 1, 6, 63 gram per mole. So this is the mass distribution there. Fine. So guys, how can we find out the molar mass? 110 gram has to be formed divided by 101, which is approximately equals to 1, and this whole is divided multiplied by 1 by 3, and this HNO3 has a something mass that we have to find out. HNO3 divided by its molar mass is 63 that we got into 4. So mass of HNO3 will be coming up as 4 by 3 times of 63 multiplied by 110 by 101. See, this value will roughly come up as 1. So see, if I multiply 63 by 4 and divided by 3, this value somehow come up as like 60. It would have been 60 to 4 to 40, 80, 90, around 80 to 90 the value should come up. I'll guess it from here. My answer should be C, 91.5 gram, because I didn't require to solve it completely, otherwise it would have taken us a lot of time, right? Let us see the correct answer. C is the perfect guess that we guessed till here. And wonderful question we had. The first question from the stoichiometry. It may appear in the examination in the terms of what should I say, limiting reagent, also one of the very important part of this topic, but I had restrictions over me. I didn't have to show all the questions. I didn't want to confuse the crowd. I have made up one paper specifically for all JEE Main 2025 students. Do attempt it with me. Always gain your confidence in calculation and concepts. Believe me, you will be feeling very confident in your exam. So many questions from here will be replicating in your examination. We have the second question, everybody. The second question I picked it from the concentration part, and also very important concentration term. The most beloved concentration term of JEE is molarity. Every time question comes from molarity. We have a question on molarity. 2 liters of 0.2 molar H2SO4 is reacted with 2 liters of, okay, so first of all we'll make a solution, guys. We'll make a solution and we'll also write down the chemical reaction that occurs over there. So we have H2SO4 plus we have NaOH, and we know what reaction does happen here. A reaction is acid base reaction. It will give you a salt Na2SO4 with 2 water molecules. Okay, that's the reaction. Now we'll find out the number of moles of every reactant given over here. 2 liter of 0.2. If you multiply molarity with this, it will give you number of moles. So 2 into 0.2 will be 0.4 moles. It is of H2SO4, and over here we have 2 liter of 0.1 molar, that is 0.2 moles of NaOH over here, right? Absolutely, sir. So we are now about to find out how many moles of Na2SO4 will be produced. These are 0, 0 at start. So now as we all can see that this will become a limiting reagent and this will become an excess reagent while the reaction will go on. So let me write how many moles will be left here. Limiting reagent will be consumed completely. So this will be remaining 0. And if 1 mole, like, okay, how are we gonna to find it? If 2 moles of NaOH are removed, then 1 moles, 2 moles of NaOH is reacted with 1 mole. So 0.2 mole will be reacting with 0.1 mole. Okay, I'm directly doing it. You also can use the mole analysis. So out of 0.2, 0.1 mole be 0.1 mole of H2SO4 will be used. So 0.4 minus 0.1 mole used. This will be giving you 0.3 moles. This is 0 moles. How many moles of this will be formed? So as many as number of H2SO4 have been used. 1 mole of H2SO4 used, 1 mole of Na2SO4. 0.1 mole which is used here will produce 0.1 mole of this, and 0.2 mole of water will also be formed. Anyways, water is always there in excess, so no need to be worried about water. Just focus on this part. Now let us see that Na2SO4 in terms of moles is how much. The number of moles of Na2SO4 we have got is 0.1 mole, and the volume total now of the solution will become how much? Volume total is how much? 2 liter of one, another is also 2 liter. So you can simply add both of the volumes, 2 plus 2, it will become 4 liter. So guys, this is what you have got it. I think now everything is with us. The question that was 2 liter of this, and the resulting product will have a Na2SO4 in the terms of millimolar. Molar as in molarity we have to find out. So first of all we'll find out the molarity, and then we'll find out the millimolar just simply multiplying with by 1000. So what I'll be doing, molarity in terms of Na2SO4 will be coming up as moles divided by volume, and this is in simply molar. So if you want to make it millimolar, just simply do 0.1 by 4 into 10 to the power 3 millimolar. So milli means 10 to the power minus 3. It's already can be negotiated with this 10 to the power 3 written over here. 1000. 100 by 4 will be coming up as 25 is the correct answer. Can I see if the 25 is correct answer? We are on the edge of the very correct answer over here. This is 25 millimolar. You got it. So very good, everybody. Does anyone has any doubt? Thank you, Mitran or Pradeep Jain. Keep it up, everybody. Keep it up and keep doing the question. That is even more importantly required here. So we have finished 2 questions, very important concepts of mole concept. Now coming to the third question of the same chapter, we have a question that I took personally from the combustion of hydrocarbon. This is a very important reaction, and definitely you will find one question of combustion of a fuel over there. I would like to give you one idea, one common idea that can be applied in whatsoever be the chapter. So let it be the practical organic chemistry. Somewhere in there also we study about the combustion and getting the percentage hydrogen and carbon. And here also we are getting the same concept. Let me remind you the concept. What does the reaction say? That we have a compound. Let's say the compound has carbon, hydrogen and oxygen. So okay, I can give you a general equation first of all. Carbon has, and percentage of oxygen in the compound we have to find out. Now it seems a quite bigger question that I was earlier expecting, but anyways we can do it. Let us say this is CXHYOZ, and this is a given compound. Compound reacts with oxygen and produces as many as number of carbon, exactly the same number of molecules of CO2 is produced. Half of the molecules of water is produced, and guys, oxygen we are talking about, so that is the product of this reaction, and energy is also eliminated out in this reaction, as these all reactions are, combustion reactions are exothermic in nature. Now my target is to find out the stoichiometry of oxygen, and it will be like 2x, or written over there 2x. We have y by 2 here. We also have z here, so I'll subtract z and then I'll divide it by 2. This is a balanced chemical equation. This is a general equation, but it's a balanced chemical equation for combustion of a compound which is containing X, Y, carbon, hydrogen and oxygen. Now don't worry, everybody, I'll give you a very fantastic way to solve this question up, but just giving you an idea. So this is a very useful concept, that if you know the amount of carbon dioxide, you can find out the number of moles of carbon. Using water, you can find out the number of moles of hydrogen. Like that we'll do. So guys, let's see how do we proceed. So we have to find out the percentage of carbon first. So percentage of carbon will be what? Number of moles of CO2. Because we know as many as number of CO2 are there, that will be also number equals to the number of moles of carbon. Number of moles of CO2 multiplied by 12. 12 is the mass of carbon divided by the mass of an organic compound 0.492 into 100. This is the percentage of carbon we'll be getting. Now can you find the number of moles of CO2, because we already have been given up with 0.07938. No, 0.7938 divided by mass, molar mass of carbon dioxide is 44. This is the number of moles of carbon also. 12 divided by 0.492 into 100. So what I can get as a value, anyways it's a complicated value. Then I'll find out the percentage of hydrogen. How? Sir, as many as number of water molecules are there, double of that will be your number of hydrogen atom, because one molecule of H2 contains 2 hydrogen. So y by 2, like whatever it is given to us, that is 0.4428 divided by 18 is the mass of water molecule, its molecular mass, multiplied by 2 is the number of hydrogen, into molar mass of hydrogen is 1. This is the mass of hydrogen divided by the mass of this compound 0.492 into 100. So guys, we have got two things here, percentage carbon, percentage hydrogen. Why am I calculating it? Because there is no direct calculation of finding out the percentage oxygen. Once you are getting the percentages of carbon and hydrogen, just subtracting out of 100 and you'll get the remaining value or remaining percentages, that is your oxygen. So can I go for this calculation if I may find anything? So this will be like, it's 9, and let's say I'm assuming it as roughly at 0.5, then what does it make? 1000, it's like 200. So 200 into 0.4428 by 9, and this value will be coming up as, if I multiply by 88.56 by 9, that is by the way, it's approximately coming up as 10%. Let's say this value is coming approximately as 10%, isn't it? Yeah, roughly. Now the same thing will apply over here. Some rough calculations, if I may, and if I can solve out this problem. So this will give you 0.5, and it will again become 200. This is 6 and we have 22 here, or we can simply make it 4 3 ja 11 over here. So we have 600 here. 6 into this, 6 into 0.8, this will be 48.00 divided by 11. Let me check the calculations once more. This is 0.5, it has become 200 into 3, 600, 6 multiplied by 8 is 48, and 0.8 is there, so it will become 480 by 11. This is 480 by 11. Okay, not a big thing, not a big task. Let's simply find it. What the value comes up? It's 4, and then it goes to 6 over there. 44 4. So 43.63%. So guys, we have got the value of what we have got it till here, 43 and 10% over there. So I can get the value of percentage oxygen, which is 100 minus percentage carbon plus percentage of hydrogen. So now please help me to find it out, and if it has been asked for the nearest integer, then we can also calculate it in our way. 43.63 and 10. 43.63 plus 10. So this will be like 44 point. Isn't it coming like 46 point 46.3% kind of? Nearly you can make it like 46%. I don't know exactly answer, but it's one of the repeated question, but 46 is correct. Okay, anyways, my target is to give you the idea. You better solve this question along with me. You might have seen me like, if I can do this question on screen with this comfortability, there in the examination hall you will be very relaxed. You should be very relaxed. Nobody is talking to you. Absolutely environment of positivity over there, and just a focused and concentration will lead you to solve this question. That's like I did. However, it is a it's a horrible question in terms of calculation what I did, but I am pretty much managed by mathematics, and I personally think that you people can also do it. Right now we have come to atomic structure, everybody. Right from mole concept, now is the time that second chapter I have picked mole concept. After mole concept I picked atomic structure of atom. And let me give you an idea of what particular topics are there that I find mostly coming in repeatedly in previous some years, and specifically a trend that has been observed right after 2020 or after 2018. The pattern has been changed, the exam body has been changed. Right after that, these questions have been come. Very first important question comes from the Bohr's model of an atom, and I personally think that the chapter itself starts from the Bohr's model of an atom only. So let's see how can you find it out. We have kinetic energy, we have total energy, or we can have kinetic energy, which are directly proportional to the z square by n square, which is a true statement I find. Number two, we have the velocity. So we have to find out how many are true. The question is over here. Most appropriate answer from the options. So you got to find out whichever the options given over here are true or correct. The product of velocity and of an electron and principal quantum number. Do you know what the velocity of an electron is? 2.18 z by n. So velocity is directly proportional to z by n. And principal quantum number is itself n, isn't it? So their product, so let's say if I write it, velocity into n will be directly proportional to z by n into n. So this will be velocity into n is directly proportional to z only. And it is saying that it will be proportional to z square, which is incorrect. So this statement is false. This is cross. This is correct. Find out the next one. Frequency of revolution of an orbital is Z3N4. I think this is incorrect, but I can give you an idea that frequency is what? Frequency is what? 1 upon time. And what is time? Distance upon speed. So this will become what? Distance upon speed. So distance is what? 2 pi r. And this is what? Speed is v. So v is directly proportional to z by n. And r is directly proportional to n square by z. So just simply solve these two, and what you will be getting, that frequency is directly proportional to z square by n cube. So this is what it is proportional to z square by n cube. So this is incorrect. This is incorrect, definitely. Frequency. And Coulombic force, what is the Coulombic force? Force is actually k q1 q2 by r square. So k into ze into e upon r square, and we all know that r is directly proportional to n square by z. N square by z raised to power whole square. So how much does it come? I guess it comes z cube by n to the power 4. Is it correct? Yes, this is correct. D is correct. Now how many options did I find as correct? A option and D option. Let us pick A and D and move forward. A and D option. A and D. I think D is the correct answer. Hopefully you all are getting what I'm trying to explain. Now D is correct. The next question, I chose it from quantum number. Why is it so? Because modern like the wave mechanical model is another important topic in atomic structure, and specifically if we talk about the conceptual part, the only concept can be derived from the or this particular concept of orbitals, and we call them quantum number. Let us read about quantum number. The first statement A says that principal quantum number n is positive integer values of 1, 2, 3, 4, which is true. The azimuthal quantum number L can have a values of 0 to 1, 2, 3 up to n, but I have no idea what this n is representing. If this n is what I must say, if this n number is the principal quantum number, then it is incorrect, because it may have, L has a value from 0 to n minus 1, 0 to n minus 1. So let me just ignore it. False statement. Magnetic orbital number, magnetic orbital quantum number, okay, has a numbers 2l plus 1, so it has a values from L to plus L and minus L to plus L, and including 0. So guys, definitely it becomes what, 2 times of L plus 1. So it's a correct answer, it's a correct statement, true. D statement says that positive and minus half are two possible orientation of spin, and S can also be positive and minus half, so this is also true. And the E statement, this is true, this is false, this is true, this is true. For L equals to 5, there will be total 9 orbital. Okay, let me guess. If L is equals to 5, what is the meaning of L equals to 5? Subshell 5. There will be a total of 9 orbital. By the way, L doesn't exist as of now, because in the let me just rethink it. S, P, D, F, G. No, it's wrong. See? So guys, L is equals to 0, S subshell, P subshell, D subshell, F subshell, G subshell, and there's not even needed, guys. I can simply do, if L equals to 5, the number of orbitals is nothing but the values of total values of magnetic quantum number, so this will become 2l plus 5, 2l plus 1, 2 of 5, 10 plus 1 will be equals to 11 orbital will be there, 11 orbitals. So I think this is another false statement, and E is also a false statement. So correct answer should be A, C and D. Can I find A, C and D somewhere? A, C and D, A, C and D, option C. I hope that you people are getting what I'm trying to explain, and even if not, just try to go through these questions. These are pretty amazing questions. These questions have been asked, and these questions are pretty much potential questions which will be definitely asked in your exam, upcoming exam. So guys, whoever is watching this video, I want to give a message to every one of you that please examify yourself wherever you right now are preparing, from whatever the corner of India you are sitting right now, or anywhere you're sitting. You can give this exam online, and it will give you an idea, and it will also give you that feeling of main exam that you're going to appear in from 22nd and onwards. So this is the All India mock test, which is going to held on 19th of January. 19th of January you can give this examination, and there will be so many slots also. You can register now, enroll now. Only in the description of this ongoing video you can find the link. The another important link, you can get it from here, which is your prediction of the All India rank. Right after you give this exam, you can put your marks and can get the All India rank, as well as the slot wise percentile also you can get, and then you can identify yourself where do you stand right now. We have one more amazing part, that Unacademy is offering you the scholarship. Not just scholarship, it's a reward program for all of those students who want to do good in their exam. So right now, scan this code, this QR code, and enroll yourself. Fill the required details and information, and right after your examination of JEE Main, Unacademy will reward you for sure. That is from my side. Now we have next chapter. Right after finishing 2 chapters that we did immediately, right now we have the 3rd chapter. Everybody, let's welcome 3rd chapter. The chapter's name is Periodic Classification of Elements, and 11th standard chapter. So I found like there are plenty of good concepts in this chapter, but out of plenty of the concepts, the most important concept that I specifically work is the periodic properties: atomic ionic radii, ionization potential, electron gain enthalpy and electron affinity, electronegativity. These 4 points are pretty much important, and so many questions have been asked previously upon those. So let's see. Okay, thank you everyone. Thank you, Shree's view. Let's see this question, everyone. Let's see, can we crack this question? Can we do this question? The question is pretty simple. The question says that the first ionization enthalpy decreases across the period. Do you think it decreases? Because I remember going from left to the right in a period, we always have seen that Z effective increases. If Z effective increases, it will take more amount of energy to remove an electron in the influence of nucleus. Ionization energy will also increase. So it's a false statement. What do you think? It's a false statement. First is false. Reason is giving that the increasing nuclear charge outweighs the shielding across the period, which is absolutely true, that I'm talking about. If the nuclear charge is increasing, which is your Z effective, then the shielding across the period also, the increasing nuclear charge basically outweighs, means dominates over the shielding. So what you can say is that moving left to right, if we go left to right, that we say that Z also increases and sigma, which is called as the screening constant, also increases. But you see Z minus sigma also increases, which is called as the Z effective. So that's why it is saying that Z dominates over sigma. I guess first is false, second one is true. Can we find any option? A is false, R is true. This is correct. Both. Now there no need to go through all. Let us check if we have done it correctly. Absolutely correctly we have done it. A is the correct answer. And believe me guys, this kind of questions have been asked previously, and these questions may asked in your coming exam also. Okay, so keep it up everybody. Try to solve these questions with me. If you face any doubt, do let me know. I'll be helping you around, of course, over here itself. Now we have another important and very amazing questions based on electron affinity. As I was talking about, it's one of the very important concept. So where can we have negative electron affinity? Do you know what is the meaning of negative electron affinity? Usually we say that electron negativity is nothing but the negative of electron gain enthalpy. And electron gain enthalpy is usually, okay, electron gain enthalpy is usually negative because the process is exothermic. Accepting of an electron is exothermic in nature. But it's not always exothermic. Somewhere it can be endothermic also. So wherever you find that electron gain enthalpy is positive, the process is endothermic, there only we can say that electron affinity will become what? Negative. So now we'll try to find out where can you find the negative electron affinity. So it happens in the cases of stable configurations, and somewhere like multiple electrons have been given to some species. So first example we have configuration 2s2. Beryllium has an atomic number of 4 and 2s2 is the electronic configuration, which is a stable configuration. And if a stable configuration is unnecessarily given extra electron, the process is endothermic. If we have to give the electron along with energy, and that's why this process is what? Negative electron affinity. Negative electron affinity. So I personally think that first is the correct answer. Let us tick it. We are talking about the stable configuration. We have nitrogen which has 2p3, a half-filled stable configuration, and again this will become an answer. Here in the case of successive electron affinity, we have oxygen with 1 electron. It gives you oxide ion. In this process, the enthalpy delta H1 is negative of A1. This amount of energy has been eliminated out. But if you add one more electron to so formed oxide, like one monoxide ion, and let's say whatever it is, we usually call it peroxide, by the way. So this O will acquire a 2 minus charge, and this process right now delta H2 has become E2, and this E2 is required positive, and the magnitude of E2 is always greater than E1. We can say this process is also an endothermic process. This is also true. This is true. What is true? This is endothermic. But sodium to this is again, I don't think there's a like anything. This is a 3s1. 3s1 can acquire electron. This is exothermic. Aluminium is already acquiring a configuration of 3p1. One more electron can be added. It is also an exothermic. So correct answer should be A, B, and C. Choose the most appropriate answers from the given below. 3? Is it 3? Guys, let's see. Is it 3? Now what 3? A, B, and C. That was the correct answer. No, A, B, and C. So A, B, and C is the correct answer. D is the correct answer. Can I check the correct answer? D. Believe me or not, this year 2025 is gonna to be the very easy year. If you have studied even up to NCRT, or if you have covered all my lectures from this channel, believe me everyone, stay confident. Likewise, your teacher, you can solve all the questions that comes in your examination of JEE 2025. And believe me, on the same day I'll be coming over here on this stage and on this YouTube live stream, will be giving you the idea that what the question has come from my taught entire year, and also from this particular test paper you'll find so many good and common questions. Now my basically idea is like that time also I'll be solving those questions in front of you, letting you know that how easy these questions are, as I am doing right now, telling you how easy these questions are. So maintain that confidence, try to grasp the knowledge, whatever it is required, apply in your concepts, and whenever you solve the question, just stay calm, stay relaxed, do not listen anything, and just maintain your vibes with the ongoing positivity, and then start solving and then crack the exam. We have done so many good questions out of periodic classification. There are also some good questions from 13th group that I'll cover in the P block itself. In 13th group, so many good questions come usually related to their ionization enthalpy, atomic radii, electron affinity. So many good questions came in 2024 actually. Now we have chemical bonding, one of the very important and huge topic we have as far as the concern of inorganic chemistry. So let's see. Yes, the similar physics class will also come, don't worry. Mathematics and physics session will also be conducted just like your ongoing chemistry classes. Guys, we have a question from chemical bonding. The first question I found is, see, there are very important topics out of entire chemical bonding. It's a huge chapter, but I personally love 2 or 3 topics which are every time you've been asked in your examination. Very one of them is VSEPR theory. VSEPR theory is a very direct and straightforward theory that has been asked previously, not in JEE Main, also in JEE Advanced. Also, apart from VSEPR theory, the application part of VSEPR is highly important, that is replicated and reflected in the case of bond parameters. This is one of the application of bond parameter. We have the correct increasing order of bond angles in BF3, PF3 and CLF3. So I will do one thing only. I will, rather than looking at the option, I will simply apply my mind of VSEPR theory. How does boron trifluoride look like? Boron has 3 electron in valence shell, and fluorine also has 1 electron each, and octet is completed, and that's how this entire story looks like. You can find out easily what is the bond angle, 120 degree. The shape and geometry will be trigonal planar. Next is PF3. Phosphorus has 5 electron, 3 are shared with fluorine itself, and 2 will be the lone pairs. Not 2 will be the lone pair, I guess 1 will be the lone pair. So this will be like PF3 is somehow like this, and this is the bond angle. So ideally, like this hybridization, okay, this hybridization is very important. So the hybridization here is sp2, so hybridization here is sp3, because there are like 3 bond pair, 1 lone pair, steric number is 3. This angle theta should come a bit lesser than 109 degree 20 minutes because of the bond pair lone pair repulsion. Now we have the third example with us. The third example is of ClF3. Chlorine has 7 electron, 4 electrons are remaining vacant, 3 are shared with fluorine. It's showing you 5 steric number. That means it will be having sp3d2 hybridization. So what you think as an hybridization, we see that hybridization will be sp3d, and this bond angle will be theta. This is nearly 90 degree. So now can you identify the differences of the bond angle? Maximum will be possessed by boron trifluoride, then PF3 and then ClF3. I think C is the correct answer. So guys, I personally don't find any of the questions difficult. The only difficult thing is the fear that is inside us. If this fear goes away, there is no question that you can't solve. It's been a complete whole package of the year that we already have. Even if you see anything at once, it has been already seen by your eyes and your mind has seen it. Now at the time of examination, what is required is the complete focus. How am I gonna to solve these questions on board? Even if so many people are watching me, so many crowd over there are sitting, my office people may see me, I'm doing the calculations, I might hesitate. It's a very natural thing, but I just close my eyes, I synchronize everything, and I think all the positivity right now is with me, and that's what we have to follow in the examination cell and examination hall also. Nobody is there who's gonna to disturb you. It's a complete silent environment you'll be getting. Maintain your, just gather your energy and just throw it on the paper and crack it. Let's see the another question from this, and I told you exactly a moment back that the most favorite topic of this entire chapter is VSEPR theory, bond parameters, and molecular orbital theory. These three are the one that has been asked repeatedly in the past few years, and that's what I looked for. I saw so many questions from 2020 to 2024, and I found there is a like repetition of these same concept and same kind of questions. We have plenty of molecules over here. The question simply says that the number of species that will be following which square pyramidal structure, which of them has a square pyramidal structure. So basic condition of square pyramidal structure is, first of all, it must have a square pyramid, like octahedron geometry it may possess. So anyways, we'll come up with every single one. Phosphorus has how many electron? 5. All 5 are shared. All 5 are shared. The geometry or shape is like this, which is called as trigonal bipyramidal, TBP, trigonal bipyramidal. The very next we have BRF4 minus. Bromine has 7 electron, 1 more electron is added to bromine, and bromine, after accepting this much number of electron, it gets 8 electron. 4 are shared here, 2 will be above and down to each other. This is a planar. We call this structure as square planar. Are we supposed to make square planar? No, we are supposed to find square pyramidal. Anyways, let's pick the another IF5. I has 7 electron, 5 are shared, 1 will be the lone pair. So now I think this is what we were actually looking for. This is a square and this is a pyramid. We have to hide, while finding the structure, you have to hide the lone pair. This has become square pyramidal. So at least one we got. Then we have BRF5. BRF5 has the similar structure. BRF5, like IF5, BRF5 also has the similar structure. BRFFFF. One more F over here, and then simply lone pair. Then out of XCO4 and ICL4 minus, we got to check it out. Let us see if I'm talking about XCO4. So XC double bond O, F, 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 F. 6 electron have been showed. Have been like this is also square planar, pyramidal, square pyramidal. And then last one is ICL4 minus. I don't think it will be having, because it's exactly the same that BRF4. BRF4, ICL4 are exactly the same. What was BRF4? Like that, with 8 electrons on iodine. This is how the structure will look up like. So the correct answer should be, I guess, 3, because 1, 2 and 3. These 3 molecules are having square pyramidal shape. Can you find the correct answer, everyone? Can you find the correct answer? Let's see the correct answer. 3. Oh my God. I want you people to have this confidence, because anything is possible if you have full of your guts, full of your energy, full of your concentration in the examination. Don't focus on anything that you do not know. Only focus on what you know, and then you will even crack out those questions which you haven't studied, because chemistry is more or less like combined. It has the concepts which are linked with each other. So even if you study like from A alphabet to, let's say, X alphabet, like 24 alphabet you have reached, you still are remaining with 2 alphabet of Y and Z. Y and Z can also be covered by yourself just after covering up to X, because chemistry is more or less connected. Even if you are very much comfortable in rest of the chapter and remaining chapter you haven't performed till now, you can also solve the questions of these. But very important part is always go solving for the easier questions first, and the one which you know about. Don't fall into those questions which you have no idea upon, because confidence is the key. Once you get the confidence, you can beat any of the strongest opponent you want to do. We right now are having one more question that simply says that according to the molecular orbital theory, the species among the following that does not exist, you got to tell them which species does not exist. We have oxide ion here, We'll simply find out the bond order, and I know the technique of finding the bond order. For all the one which is having more number of electrons than 10, you can apply the concept like 16 plus 2. So this is like 18 electrons are there. So 18 electrons will be 4 electrons far from 14. So remove 3 minus 4 into 0.5. So it will be like 3 minus 4 into 0.5. So this will be getting your answer as 1 is the bond order. So this has one bond order. Beryllium. How many electrons are there in beryllium? 4. Hydrogen, helium, lithium, beryllium. 4 plus 4, 8 electrons are there. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Number of electrons in bonding and antibonding are equal. Bond order becomes 0. That is equals to 4 minus 4 by 2 is equals to 0. So this 0 bond order means no bond exists between beryllium and beryllium. Means Be2 molecule doesn't exist. It's that simple. So this is as per as the application of molecular orbital theory. The correct answer should be B. You may apply your concepts on remaining one also, but I personally think that B is the only answer. It's a single choice type question. Helium has how many electrons? 1 hydrogen helium. 4 plus 4, 4 hydrogen helium. 4 minus 1, 4 plus 1 will be 5. So bond order will be sigma 1s2, sigma star 1s2. So it was like 3 minus 2 by 1, that is 0.5. And even in He plus, bond order will be 2 minus 1 by 2. So 0.5, these exist. Only species that doesn't exist, beryllium. Can I find the correct answer? Yes, why not? The correct answer is B2. That's it from my side from chemical bonding. It's a huge session we are right now having. We till over here have finished 4th chapter. We are going in a very smooth way, very fast way. Believe me, it will take us another couple of hours, but we will finish this complete session of 50 or near to 50. It's even plus 1 or 2 questions also, including your practical chemistry questions. So I personally find that we are going in very smooth way. Now let us solve some questions from redox reaction, one of the very favorite topic of mine from this entire chemistry, and completely mathematical, completely easy chapter. We have sum of XYZ will be what? These kind of question might not replicate in the similar way, but in the like you can find the same questions in so many different ways, and the balancing of things is very easy. And specifically if you talk about balancing of Fe2 plus with respect to dichromate, it's a very important reaction. Now I'll give you the way how can you solve these questions and how can you balance it. Whenever you take, just simply pick those species which are undergoing oxidation and reduction. Cr2O7 is the strongest oxidizing agent. Definitely it will be coming up in your main exam, main equation. Then you have iron 2 plus, and on this reaction they produce what? Reaction is undergoing in acidic medium because H plus is given, but don't need to write it in the main equation initially. Then you will make Cr2 plus, 3 plus, and we have Fe3 plus because iron is oxidized from 2 positive to 3 positive. Now can you find out the oxidation states here? It is positive 6, it is positive 2, it is no, let me change the color, otherwise it will get mixed. This is positive 6, positive 2, positive 3 and positive 3. Guys, from positive 2 to positive 3 the n factor will come up as 1. But from 6 to 3, the n factor may come up as 3, but 3 into 2 we have to do because we are calculating the n factor for dichromate ion. So wherever the tail is starting and it is the arrowing towards something, the tail thing we are n factor finding off. This is 6. Now you cross multiply these two, 1 and 6. Let's see what you get. So right after cross multiplication, what will be getting? This will give you simply Cr2O7 2 minus plus 6 times of iron 2 positive, and gives you 2 times of Cr3 plus I'm making in order to balance chromium in left side and right hand side. The multiplication was required for these two only, rest will balance it by myself. 6 times of Fe3 plus has also to write over here. This is some equation where you have equated number of electron lost equals to gained. Now right now from here you start balancing the number of oxygen. You have 7 oxygen, you just put a 7 H2 here, as many as number of water you are applying here. twice of that hydrogen is added here. Simply left hand side 0 hydrogen, right hand side it has 14. I'll put a 14H positive over here. Now X, Y and Z were asked, can you compare your equation with this main equation? What you'll see, you will see that X is 14, Y is CR3 plus is 2, and Z is how much? H2 7. So guys, their sum will come up as 14 to 16 plus 7 23. 23 is weird answer. Can we see 23? Or 23 is correct, everybody. So the only thing that right now is working is the confidence. You have this confidence, you apply it, and you will be getting whatever the success you want, you will achieve it. Today or tomorrow, you will definitely make it done for you. That was the first question. I gave it from the balancing of redox reaction. The most important part of entire redox reaction is the balancing. Right after balancing, the even more important part becomes your application of redox reaction in terms of redox titration. So I'll give you one more question from redox titration. Let's have another question. The question simply says that the density of a monobasic acid, strong acid, is given to us. Molar mass is 24.2 gram per mole and it is 1.21 kilogram per liter. The volume of its solution required for complete neutralization of 25 ml of 0.24 molar NaOH will be what? Initially, what you need to find is we got to find out, by the way, monobasic acid is there and complete neutralization, volume of solution required. The volume will be needed once we know how much density is also known to us. Anyway, so we'll see that the at equivalence point, gram equivalent of an acid becomes equals to the gram equivalent of base. Gram equivalent of acid, we'll come to know it's monobasic, so its number of moles of an acid will be can be identified using this reaction. It will be having molarity volume into n factor. So molarity is given to you 0.24, volume is 25 ml into what is the n factor of base is 1, and we'll multiply by 10 to the power minus 3. Why? Because this is what we are trying to do. So the number of moles of acid comes up as 25 into 0.24 into 10 to the power minus 3 moles. That's the first thing we did. Now it is asking, what is the question have been asked? The volume of the solution required. So guys, you can also find out the what should I find here? I'm not getting the concept exactly. Molar mass is given to you, so you can find out the mass. Okay, then you can find out the solution also. Okay, that's what we are doing. So then only we will finding of the solution. Density of monobasic strong acid is 1.21 kg per liter. So using this data, we can find out the mass of an acid, mass of the acid, number of moles of acid multiplied by molar mass of an acid. This mass will come up as 25 into 0.24 into 24.2, it's gram per mole, and multiplied by 10 to the power minus 3 grams. but I'm finding the mass of, from this calculation what I can find is only the mass of an acid, not the mass of solution I'm getting. So how should I use that 1.21 kg per liter thing yaar? Density is given there. And its molarity is also not given to us. Okay, we can find out the molarity by the way. Assume that its volume be V liter, or like volume be V ml. So using V ml you can find out the mass of the solution. So out of mass of the solution, actually I got a bit confused here, but anyways I'll try to do it immediately. We have gram equivalent of an acid and base over here. We find out the number of moles of an acid, so we can find out I'll do it in one more way. Let's see if I reach to the correct destination. We'll see that let the volume be V ml. This volume is what? V milliliter. So mass of solution I will know about it, but why do I need it? It's a bit confusing, yeah. Let me retry. Got it. So this is what we are having, pure acid only. So that's why this is given up like this, 1.21 kilogram per liter. So guys, you already know for this acid solution, 1.21 kilogram it weighs of 1 liter. So it's like how much is the mass we are having. So on base of that, so since you can see that 121 gram solution has 1 milliliter, that is the meaning of 1.1 kg per liter, or you can make it gram per ml, it's the same only. So that's why this mass, this W of acid will having a volume of how much? So 1 upon 1.21 into mass of acid is how much? 25 into 0.24 into 10 to the power minus 3 into its molar mass is given 24.2. Just solve this and you will get your answer. Just simply solve this and you will get an answer. So like 20 500 into 0.24 into 10 to the power minus 3 we are getting. And this much ml. 0.12 ml we are getting as the answer. So I think 12 is the correct answer. Is to oh yeah, how easy was this question? So I got confused once at the point where you know what this was giving to you. I remember the moment we are solving this question, I thought it's an aqueous solution, but anyways it was directly related over here with the given mass and volume. We made it. There were two questions I tried over here, two questions we made it from redox reaction chapter. So guys, we have finished till here, complete 11th, almost like completing your mole concept, atomic structure, periodic classification, chemical bonding, redox reaction. We have the 6th chapter of the day, everybody. 6th chapter of the day, we have chemical equilibrium. So the more important part of chemical equilibrium, I find personally, is first of all the application of equilibrium constant. So equilibrium, application of equilibrium law, how do you apply it? And then right after equilibrium constant and equilibrium related questions, we have one more important parameter called as Le Chatelier principle. I have seen so many questions previously, specifically after 2020. So many questions have been asked about this topic, and it's a very huge importance topic. We have first question right now. Equilibrium constant at 298 Kelvin is 100. Then the initial concentration of all these species taken as 1 molar, then equilibrium concentration of D will be what? So first of all, let us understand what is this question saying. And very good evening, Rajia. Very good evening, beta. Now please solve these questions with me and submit me your answer in comment section. I'll be glad. We have a question in which it has been said that A and B are reactants in equilibrium with C and D as product. And when the time just started, we all had 1 molar each of these species, 1 mole, 1 mole, 1 mole, 1 mole, let's say. Then you all know that at equilibrium, let's say some of the reactants have, what should I say, reduced or dissociated, and some products have been formed. In case like the reaction could have gone in opposite way, the whatever we are breaking may come in negative also. So this will be like 1 minus x. 1 minus x. It can also be written as alpha, because from 1 mole alpha is dissociated. This will become 1 plus alpha or 1 plus alpha. So what is the value of Kc here? Kc will become 1 plus x into 1 plus x upon 1 minus x into 1 minus x. So this is like, this is how it is looking like, right? Which is equals to, it has been given to us. No, it's not given. The equilibrium constant at this is 100. So this is actually what? 10 to the power 2. So on solving, what you'll be getting? We get 1 plus x upon 1 minus x is equals to 10. So 10 minus 10x is equals to 1 plus x. So we have 11x is equals to 9, and x comes up as 9 by 11. So the concentration of D at equilibrium will be what? 1 plus x. So 1 plus x is what? 1 plus 9 by 11. So 9 by 11 will be what? 1.8, approximately 1.81, 1.818. No 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 no. So correct answer should be what? 8.1. I think B is the correct answer. So one of the very easy question, one of the very application based question we all got, and that's how we do it. The very next question I took it from Le Chatelier principle, one of my favorite topic, and you will find one question, similar question over there in your exam, and might be the same. Let's have the question. SO2 plus O2, its first of very all is an exothermic process. This reaction is exothermic. The amount of heat is released is 190. It has been supported by lowering the temperature. So is the number of factor which will increase the yield of this reaction. So can increasing temperature yield? No. Pressure. Guys, if pressure increases, overall concentration means the number of moles per unit volume also increases, because we know on increasing pressure volume decreases. If concentration decreases, the reaction will try to go into that direction where you have lesser number of gas moles. Gaseous number of moles on reactant side is 2 plus 1 3. In product side is 2. So yes, reaction goes in forward side. Very right. Goes forward. It's very right. So another, it's a correct thing. I guess it's a correct thing. Adding more SO2, the reaction will go in forward direction. On if you are adding the reactant, if you are adding the concentration of reactant, reaction goes forward direction. Correct answer C. By adding more oxygen, obviously one of the reactant, the same reason is here. This will also. An addition of a catalyst. So catalyst always helps. Okay. In order of like if it's a positive catalyst, so its positive catalyst leads to attain the equilibrium faster, but does not help. No, I don't think it's the correct answer. Sorry. So only helps to attain equilibrium faster, but once the equilibrium is attained, no change will be implemented. No change on equilibrium. Once the equilibrium is attained, no change will be seen. Can I find the correct answers, everyone? It's 3 factors are given. How many factors did I give? 1, 2 and 3. That's how we do it. That's the confidence we want in every student. Correct answer should be 3. And I can give you what these 3 factors are: increasing pressure, more adding SO2 and O2. So right after finishing chemical equilibria, we have one more. It's brother, ionic equilibria. The elder brother we have, ionic equilibria. And ionic equilibria has so many good concepts and so many important concepts. But out of these all concepts, what concepts I find are the most important? Very good evening and very energetic evening to everybody. But I would expect you people to solve the questions with me only, along with me, so that I also get the equal confidence. So I was telling you that out of this entire chapter of ionic equilibria, some of the important concepts are calculation of pH for the weak acids and common ion effect or some mixtures of the acids, and it can mostly question comes from the buffer solution and solubility product. Definitely will be question there of solubility product, and then we have salt hydrolysis, one of the very important part. So I'll do one of the few questions, and that is one taken from the buffer itself. See, 1 liter of a buffer solution contains 0.1 mole of each ammonia NH4Cl. 1 mole of each is there, ammonia and NH4Cl. Okay. On addition of 0.02 mole of HCl by dissolving gaseous HCl, addition of 0.02 moles of HCl by dissolving gaseous HCl, the pH of solution is found to be what? No, it doesn't look like an easy question, by the way. Okay, so guys, what is happening first of all? Come. Initially, we have NH3 and NH4Cl already in the buffer solution. This called is buffer. This buffer is basic buffer, where both of them are 0.1 mole and 0.1 molar. Okay, so 1 liter is the solution, 0.1 molar, 0.1 molar. Till here we are absolutely fine. But now something is happening, that we are now introducing 0.02 molar of HCl unnecessarily. I don't know why they are implementing it, but anyways, let's see what happens by introducing 0.02 molar HCl. So this NH3 plus HCl gives you NH4Cl. So this was 0.1 molar. Now this will be 0.02 moles, and I'll simply write it in the terms of moles itself, 0.1 mole. This is 0.02 mole, and this was already 0.1 mole. So this was T is equals to 0. The T is equals to T time. What will happen? These reactions will carry on. The limiting reagent is this. This will be 0. This will become 0.1 minus 0.02, which is equals to 0.08 mole. This will also be how much? 0.1 plus 0.02. So this will become 0.12 mole. See, now we have, this is your weak base, this is your salt of weak base and strong acid. You got to find out the pH. The pH formula is very simple. You have to find out pOH here, which is pKb minus logarithm of salt by acid or salt by base. So this is pKb. How much is pKb given? pKb 4.745. Sorry, 4.745, 7 or 4.745. How much is the concentration of salt? NH4Cl is 0.12 divided by 0.08. This is your 12 by 8, can also be written as 4. Sorry, what should I write it for? 3 by 2. 3 by 2. So this will be 4.745 minus log 3 minus log 2. How much is log 3 given here? 477, 0.301. So this value comes up as 7 minus 1 is 6. 7, 1, 0.176, 4.744 minus, this will be coming up as 4.569. This is pOH. What is calculated, what is asked in this question is simply pH. So pH will become what? 14 minus pOH if the reaction is happening or everything is working under 25 degrees Celsius. So this will become what? 14 minus 4.569. I guess the correct answer should be 9 point. This will be 1 and 3 and 4. 9.431. 9.431, I guess. 9.431. 9009. Oh my god, we have committed some mistake anywhere, I guess, maybe in solving or, but anyways, we know what was required and that's what we do. 0.477. Okay, we have done it incorrect here. This is actually added. It is added. So this will also become added. That 4.745 plus this much will be what? $4.921. So now subtract 4.921. Then what should be the answer? 9 and then 7 0.9. 9.079, and you can also write it like 9079 into 10 to the power minus 3, because in terms of minus 3 it has been asked. 9079, exactly the same answer we have got. So that's the beauty. 9079, that's the beauty of having the confidence that yes, we can do it. We have made it throughout this year. Now we cannot hesitate at the end of this very special time that we are right now having. We have another question related to the solubility product, and believe me, this question will be appearing in your exam. Maybe the salt could have been different, but yes, similar kind of question will come up. The question is simple, that molarity, the molar solubility in mole liter inverse of a spherically soluble mx4 is S. Then how do we represent this? So see, this is mx4, and on ionization it will give you m4 plus 4x minus, and the equilibrium We do not write anything for solids. We'll keep it as neglected. Yes, these two are the aqueous ions. We have to write the solubility as S. This will become 4S. So what will be the value of Ksp? Ks will be S to the power 1 multiplied by 4S raised to the power 4. So 4 into 4 is 16. 16 into 16 is 256. S to the power cube. So solubility will come up as, it's Ksp divided by 256 raised to the power 1 by 3. The correct answer should be, I don't know which one. Okay, this was not 3, this is 5. Power 1 by 5. Can you find somewhere? 256 Ksp by 256 D. I think D is the correct answer. Is it, guys? D is the correct answer. Can we get it D? Yes sir, definitely D is the correct answer. So that was ionic equilibria, and the final chapter of physical chemistry right now we are having is thermodynamics from 11th standard, and then we'll come up to 12th standard chemistry, which is more or less, it's having organic chemistry specifically. But until then, let's start solving thermodynamics. Thermodynamics is given with so many fascinating graphs where you can find out of this PV curve, you can find out the work done by simply work done area under the curve. The magnitude of the work done undergoes reversible expansion. Expansion means we are going in increasing like from A to B, B to C. So guys, it's simple that work done reversible specifically if we find out, and is equals to area under pressure volume curve. So what area can you find under pressure volume curve? This is the area we are talking about. Only don't spoil this graph, but we can do one thing. Maybe it will come up as 8 only. I don't know exactly, but maybe. So guys, these are two things that you have to find out. The area, first one will be it's a rectangle or what? So 2 to 2 we are giving now. Yes, it's a rectangle. So 2 comma 2 is, it's 2 actually. So 2 to 8 is 6 into 6 is the first pressure volume. So this is Pascal into meter cube, and believe me, Pascal into meter cube is also equals to joule. SI units are produced or multiplied, plus another half of the base into height. So base is 8 to 12 is 4, and height is from there to there it is 6. So it is 12. So 36 plus 12, like 48 joule we are getting the answer. Can I find the correct answer? 48 joule. There you go. There you have it. So there you have it. The correct answer is 48. Made it, everyone? Yes, we made it. The next question from thermodynamics, we have another question from thermodynamics. Thermodynamics question says that the standard entropy change for the reaction iron is reacting with oxygen giving you iron oxide is this. The standard entropy change, which is delta S naught is equals to minus 550 joule per Kelvin. That's the unit. And temperature has been given 298. The standard enthalpy change for the reaction is minus 165 kilojoule. If the delta H of the reaction is given to us, then what is the temperature at which reaction attains the equilibrium? If the standard enthalpy change is this, then at what this? But anyways, this is something very cool and very easy questions. I find that, see guys, what happens that at the rate specifically we talk about that equilibrium. At the rate equilibrium, the delta G naught will become 0. So wherever we apply that, delta G naught is equals to delta H minus T delta S, and then the expression becomes equals to delta H naught is equals to T into delta S. So for a chemical reaction, I'm writing these terms. Okay. Okay. The standard entropy change for reaction is this. Okay, and reaction goes nowhere, reaction is in equilibrium, then this happens. Okay, so using this data, can I identify the value of temperature? So do one thing, that temperature will become equal to delta H naught upon delta S naught. How much is delta H? Uh, 550, right? No, 165. So negative of 165 kilo 10 to the power 3 divided by 550 negative. This will be cutting down. 555 to 316. Oh my god, that's very simple. No, it's 300 Kelvin only. Okay. This is a very important expression, and this is very important expression I write. It's a Gibbs equation or Gibbs-Helmholtz equation. So guys, this is the Gibbs equation, and it's very important among this whole chapter. 300 Kelvin. Finally, we got it. Absolutely correct, guys. Absolutely correct. We got it. That was some very good questions came from the freshly prepared thermodynamics we had. Now we'll come to solutions part. So guys, this is my predictions which right now are going on, and you are receiving the most expected question right now. You might be seeing right now explaining these questions over here on this channel. A day or couple of weeks later, you will find these similar questions in your main exam. Yes, everybody, not just couple of weeks, it's just a week now. We have the next chapter itself from 12th standard directly. We have finished all the physical chemistry questions and inorganic chemistry chapters from 11th standard. Now we come to 12th standard. The very first chapter is solutions. Solutions is having one of the very advantages in terms of concentration part, because this is something that we cover in mole concept also. So the most important topic that come from solution chapter are their colligative properties and Van 't Hoff factor. Two things are very important: colligative property and Van 't Hoff factor. Talking about colligative properties, in the Raoult's law sometimes have been asked, sometimes delta TB, delta TF, and these kind of questions mostly come, and even your osmotic pressure also have been asked sometimes. Now let's see question. 2 gram of a non-volatile electrolyte solution, which solute is dissolved in 200 gram of different solvents A and B, whose ubilioscopic are in 1:8, then the elevation boiling point of this. I think I have picked a very worst question and most easy question right now, but I can give you. So 2 gram of non-volatile electrolyte is there, and something. So 2 different solvents are there, okay? 200 gram of different solvents are there. So see, we will write it like delta TB is equals to I into KB into molality. So this I is actually, it's a non-electrolyte. So no doubt I becomes equals to 1. KB is something which you have to find, and molality can also be written down as, molality will become what? Given mass 2 gram upon the molar mass of solute. Molar mass of solute into 1000 upon 200. So that's how we represent the molality term also. So if you talk about the ratio for these two, there are like two things which have been given to us. The very one of them is delta TB in the case of A divided by delta TB in the case of B. Their elevations are given on. This is exactly equals to, this is actually X by Y. Delta TA, delta TB. Okay, so how will you do it? How will you do it? Its I is cancelled out. KB of A upon KB of B into, now talking about the same thing, that 2 by M solute will be cancelled out into 1000 by 200. I think this will also be cancelled out. What do you think? It's the same thing which we are writing, because molality will be the same, because amount has been taken exactly the same, 1000 by 200. So this will be whole cancelled out. So this has becomes exactly the same only, and KBA by KB is given to you 1 by 8. Then I think this will also become 1 by 8. So this is your correct answer. So I think this X by Y is nothing but 1 by 8. Can I find the correct answer? 8. So value of Y has been asked to us. X by Y is this. So Y will become what? 8. It's correct. I found this question as very easy, because The only question was related to the concept and mostly the so that's it. That was a good question we had, everybody. Hopefully you all have liked it. Now we'll move forward to the next question. It was not a likable question, by the way. Worst question we have seen. But yeah, now we have a good question on a very important part of this chapter called as what should I call it? Raoult's law. So we have a question on Raoult's law. Okay, so let us read one by one everything. We have a 35 degrees Celsius and vapor pressure of CS2 is found to be 512 millimeter. Mercury and that of acetone. What is this? Okay, 512 mercury, mmHg is the unit, and acetone has 344 mmHg. A solution of CS2 in acetone has a total pressure of 600. The false statement will be what? So do one thing, everybody. Try to find out the Raoult's vapor pressure. So this is the total vapor pressure is actually, this is the real vapor pressure. If I find out vapor pressure of Raoult's, no, but how can I find it? So CS2 and acetone are less. Well, I can't say as of now. See why? This is the real vapor pressure. But see, there is one more thing that CS2 carbon disulfide and acetone. So do these things have anything in common? I don't think anything is common in between them. So they will form a solution with positive deviation from Raoult's law. Why? Because of the nature of these two compounds. Whenever two compounds are having nothing in common, whenever two compounds literally repel each other, kind of situation is there. If two compounds attract each other, then it becomes a negative deviation, because in that way molecules will be bound to attract each other. They will not release too much of the vapors, but here it will release too much of the vapor because there is no as such interaction between these two molecules of acetone and carbon disulfide. One of them is polar, weakly polar, acetone. Another one is absolutely non-polar, which is CS2. So there is no as such interaction between these two. This is a solution with positive deviation. So with positive deviation, what you'll find, CS2 and acetone are less attracted, correct? And that's why they then themselves they are less attracted. This is correct. This is also true. Then a mixture of 100 ml of this, 100 ml of this acetone has a okay, this is incorrect, because if 100 ml is there for a positive deviation, this happens in the case of a negative deviation. In negative deviation, the delta V comes negative. Delta V comes negative, means final volume will be lesser, but here it is it's lesser, but the solution is having positive deviation. It must have over 200 volume. So this is the false statement. I think this is the only correct answer. Rest we can check. Heat must be absorbed. This is true because it's a positive deviation. And Raoult's law, it is not obeyed, as we all know. That's why I think B is the correct answer. There you have it. So B is actually that question. So B statement is correct. B is the correct option here. And this question is taken from the deviation from the Raoult's law. We have taken it. So that was the most basically trusted topics I picked it with. One of them was related to the colligative property, another one on the deviation from the Raoult's law. Now we have electrochemistry, your beloved and the most loved chapter from 12th standard. And because in 12th standard, specifically talking about JEE Main, we have specifically 3 chapters. And we are very lucky that we are having electrochemistry with us as a very good chapter, electrochemistry. Guys, let's have one question. The standard reduction potential at 298 Kelvin for the following half cells are given below. So we have plenty of cells here, and E0 for this is given here. It's a reduction happening over here. So undoubtedly this will be taken as what should I call it, as a cathode. Somewhere reduction is happening, this will be taken as cathode. So what I have to make is, make it is at E0 of anode. So E cell should be E0 of cathode minus E0 of anode, and in order to work this should be positive. For spontaneous working it should be positive. So E0 of anode, which is also SRP, and this is also SRP, and we also have this much number of options with us to make this cell, and we want to find out where it can work. So what I'll do is where we can find out this SRP is coming less negative, because it is already positive, minus this. So SRP over there written is should be what? Lesser than 1.33 volt. So where can you find SRP lesser than 1.33 volt? This is correct, this is correct, this is not correct, this is also correct. So I think 3 is the correct answer. 3 options are there. We can where you can have spontaneous working of a cell. E0 cell will come up as positive. If you apply the same reaction for delta G, which is the net useful work done that come out of the cell, which is negative of NF E0 cell. Delta G, higher is the negative of delta G, more is the efficiency of the cell, and we also get E0 cell over there as positive. So no doubt we are getting the concept. 3 is the correct answer. And what should I say now, guys? Like the way we are approaching these questions and the way we are solving everything, now it has become very easy to all of us solving these questions. With this continuity, like the very first topic I find very important in this entire chapter of electrochemistry is this topic, that was electrode potentials and all of them. Now another important part of this chapter I find is now this working of what should I say, the conduction, conductor, resistance, resistivity, then molar conductance and all. This is very important. So we have some question here with us, everybody. Now read it and then give the answer. Resistance of the conductivity cell at cell constant of 129 meter inverse is filled with 74.5 ppm of solution of KCl, and it is labeled as 100 ohm in the solution number 1. When the same cell is filled, okay, so first of all you do one thing, that you already have got the G star, which is actually the cell constant. You will apply the same constant in the next one also. And when the cell constant is filled with KCl solution at 149 parts per million, the resistance is 50 ohm. So the ratio of the molar conductivity of the solution 1 and solution 2 is what? Okay. So molar conductivity is something that we have to discuss now. So ratio of the molar conductivity is we have to find out. Okay, we can do it. So guys, what does it need, by the way? I remember that lambda m was K into 1000 by capital M molarity, and it's like in gram per liter. So anyways, these two concentrations are directly related. Molarity directly proportional to parts per million also. So they can be interderived from each other. Or first of all, we have to find out the conductivity kappa for all of these K1 and K2. So kappa 1 can be identified as, since R is equals to rho L by A. R is equals to rho L by A, everybody. So we have anyways, some interruption arrived and I have responded them well. Yeah, so R was rho L by A. So there you have rho is equals to, or you can also say that the L by A is actually G star. So rho will be equals to what? R by G star, or rho 1 by rho. 1 by rho is equals to kappa will become equals to G star by rho by R, resistance. So now it's very perfect. We can find out whatever we want. Kappa 1 and kappa 2 will be getting directly from here. Now let us apply this direct formula of lambda 1 by lambda 2. Lambda 1 is what? Kappa 1 into 1000 by its concentration, molarity, which is directly proportional to the initial concentration, which is 74.5 ppm, and this will be divided by kappa 2 into 1000 upon molarity, and the next molarity is what? How much? 149 parts per million. So you just solve it and you'll get your answer, I guess. So now do it, guys. This is removed. Lambda 1 by lambda 2 will be equals to kappa 1 is how much? R by G star. So G star by R. So 1 by R. G star will be cancelled out. 1 by R is how much? Initial initial is 100 into 1 upon 74.5 divided by 1 by 50 into 1 by 74.5 will return as 149. Just solve it and you will get your answer. So how much is it coming, by the way? It's 50 into 149 divided by 100 into 74.5. So this is 1 2, this is 1 2. I think this is coming as 1 only. So if this coming as 1 in terms of 10 to the power minus 3, it will become 1000 into 10 to the power minus 3. Is the answer 1000? Thankfully 1000. So this question was a typical calculation based question, but anyhow we made it because we know how can we like go through this question and how can we make it done. You better read out this question from here, try to solve this question by your own, and in lack of our time I have to move forward directly, guys, rather than stopping somewhere. So we have the next chapter is chemical kinetics over here, and before chemical kinetics I would like to give a small break, everybody. I have a little bit of urgent work arrived, so I'll come back and join you shortly. So we have a small break and we'll be connecting in just 15 minutes, so don't go away. And those who haven't liked the session, please like the session right now. Only like the session. Hi guys, so I'm back. Hopefully I didn't take too much of your time. So that was a sufficient break we had. I didn't have lunch and I felt very starving and I had something to eat. So guys, we were going from 11th standard to 12th standard, completing all the chapters in our syllabus. Right now we have, allow me a sec. Okay guys, so I have an important announcement here for all those who are appearing for JEE Main 2025. We already have planned some sessions and those sessions are right now live. You can find on live segment of our channel. Go there right now only and notify, and as per on your shift, whatever the shift you want to see the solution for, we will be live. The entire team of our Unacademy in English will be live there to give you the solution of what should I say, the guess questions. Okay, the guessed questions. Now we'll come up with chemical kinetics, a chapter from 12th standard. The most important part of this chapter I find is the integrated rate laws, and next to it will be Arrhenius and this collision theory. These two are the very important part of this huge chapter. So we have the first part of this chapter coming from first order kinetics. This question is T 87.5% is the time for 87.5% completion, no doubt. And T50 is the half-life. So the relation between these two will be what? Anyways, we can do it in this way that we have this T half is equals to ln2 by K. So K will be coming up as T half, sorry, ln2 by T half. Now apply this in the integrated rate law, that and T50% is given to you as T half or T50% only. So T 87.5% completion will be equals to K is already given to you, ln2 by no, it won't give you any answer here. I think we must do it separately. ln2 by K is your T half. So K comes up as ln2 by T half, but no, it's not giving any outcome to me. We have to compare them. So there is one way I can do it, like T 87.5% will be equals to 2.303 by K logarithm of, so 50% will be A naught by A, so A naught upon A naught by 2, and okay, so 87% will become what? The remaining one will be A naught upon, the remaining one will be 100 minus 87.5 will be 12.5 A naught. Similarly, all divided by T 50%, 2.303 by K logarithm of A naught by 50%, that is 0.5. अरे क्या है यार, 0.5 A naught. So this thing into 8, so this is like equals to, and 100 upon 12.5, this is written 0.125. So I guess this will come up as 8. So T 87.5% upon T 50% is equals to, this all will be cancelled up, logarithm of 8 upon logarithm of 2. This can be written as log 8 can be written as 2 logarithm of 2 to the power 3 upon log 2. 3 comes up before log 2. I think the correct answer should be 3. Is it? Check it, guys, check it. So that's how we do these questions, and believe me, there could be a variety in this question. I have seen so many questions in 90%, 99%. Then some of these questions have been repeatedly asked in few years. So I must suggest you that whenever you go for solving this question, always think of the formula. The formula should always be in your mind. The roadmap of this entire chapter should be in your mind while applying the concepts. Okay, so that was the application of first order kinetics. We have finished it. Now we have the next question with us. A is converting into product. A is converting into product. There are two reactions in which one of them is given with catalyst, another one is at the lower temperature, and another one is at the high temperature. So it was found that EA is decreased by 30 joule in the presence of catalyst. Then if the rate remains unchanged, then the activation energy for the catalyst used will be what? Okay, so we'll do one thing. See, this is how we use it. We have a general reaction. We can write it like K or R in the terms of pre-exponential factor e raised to power EA by RT. So that's how we write it in a general expression. So let's say if the rate remains unchanged, then the activation energy of catalyzed reaction will be what? Okay, and it is decreased by 30 kilojoule per mole. So do one thing, we'll take two equations here. So K1 is equals to K2, and assuming that pre-exponential factors are also the same. Now apply the concept. So it will become A not E into minus ka EA. So this is your EA initial plus 30,000 by RT. Temperature is same or different? Temperatures are different. So ln of K barabar, yeah, we can simply make it like ln of K2 by K1 will be equals to A naught will be cancelled out. EA by RT 1 minus EA by RT2. This is 2, this is 1, like that. So this is how you can just simply make this reaction out of it by putting it ln K is equals to ln of A naught minus EA by, simply if you take ln in both sides, then it will become EA by RT. So that's how we have made it. Okay, fine. Now what should we do? We did K2 minus K1, it become like this, and now it is a perfect balanced equation we have, and we can use this equation to find out whatever we need. So this has been said that this value K2 by K1 is same, this is 1, so ln of 1 is equals to 0. So we can say simply that EA1, so this ln of 1 is what? 0. EA1 by RT1 must be equals to EA2 by RT2. Using this formula, what we can derive is EA1 is what? Some E energy plus 30,000, 30 kilojoule is extra, upon temperature is how much? Initially 700 must be equals to 500 temperature, and simply E. Solve this equation, you will get your answer, everyone. Solve this equation, please. So 5E plus 15, 1,50,000 is equals to 7E. So E will come up as, I guess, 75,000 joule or 75 kilojoule, I guess. Is there any option of 75? I don't know. I can't see. Okay, it's not visible But yes, this D is the option where we can get the answer of 75. Getting me? So that's how we do it. That was one of the very easy questions we had. Very easy question we had, everyone. Hopefully you all have enjoyed this question, and also this question gave us the conceptual idea that how we should apply the formula and how can we get to the final value. And there we end this chapter. We have 2 chapters remaining from inorganic chemistry, P block, D and F block, and coordination compound also. So we'll finish them, which is now 12th class has been started. So we have a question. So whenever we talk about P block, the most important part of this chapter is 13th group, and so many questions have been asked frequently from past few months, from past few years, from past few decades. Okay, it's okay. Now come back to the topic. We have some of the correct statement from the following will be what? Statement 1, the decreasing order of atomic radii is in this order. So in see, boron, aluminium, indium, gallium, boron, aluminium, gallium, indium, thallium. So thallium is the largest, indium, and the only difference in the size is in gallium. So I think this is true. Are you guys getting what I'm trying to explain here? This is not true, this is false. This is the incorrect portion. Aluminium should be larger than gallium. Poor shielding of D block, D subshell. So this could be false. Then next question is down the group 13th electronegativity decreases from top to bottom. Top to bottom. Down the group 13th group electronegativity decreases from top to bottom. Electronegativity, does it decrease? Even I forgot, let me check electronegativity order. No. So it is like boron, and then aluminium has the lowest, and it's like incorrect because this is the order. Boron has the one, then thallium, then indium, and then gallium, and then comes the aluminium. So this is the order which is of electronegativity. Again, this statement is also false. So what I'm saying is that 13th group is very important. You should go visit all the trends related to all the periodic properties. Let it be the electronegativity, electron affinity, ionization potential, ionization energy, or atomic radii. Aluminium dissolves in HCl and liberates hydrogen gas. True, which is true. All metal react with acid, liberating this, typically the active metals. But concentrated HNO3 renders activity by forming a protective passive layer. So this statement is true. I have mentioned it true. Now D. All the elements of group 13 exhibit highly stable positive 1 oxidation state, which is wrong. Aluminium typically shows positive 3, and gallium can show positive 1 and 2, but this is incorrect. Then hybridization of aluminium in this complex is sp3d2. Okay. sp3d2. So it's forming an octahedral complex. I think this is correct. So aluminium has 3s, 3p and 3d. So 3s is already occupied, 3s to 3p 1, and Al3 plus has 3s 0. So it will be sp3d only. Correct. Only outer configuration is possible. So this is also true. I think C and E are only correct option. B is the correct answer, and B is the correct answer. So guys, until now we were having some of the questions from organic chemistry, and it might have taken us a few long time to solve them because physical chemistry takes time, usually calculations and all. But now we will be solving inorganic chemistry. We'll go like this, quickly like this. The next question is over here. Next question is says that identify the incorrect statement about group 15. So group 15, we have to identify the incorrect statement. This is also similar kind of question, and I see some of the new students have joined. Hi Pranav, hi Vicky, very good evening guys, very good evening. Yeah. What are incorrect? Dinitrogen is diatomic gas, acts like inert gas. Very good. Because of the nitrogen triple bond, it doesn't break in easily. It's not reactive gas. The common oxidation states of these elements are -3, +3, which is true. Check out the electronic configuration, you'll come to know about it. Nitrogen has a unique ability to form p-pi multiple bond, which is true. Multiple bonds. The stability of positive oxidation state increases down the group, which is not true. This is false. Because of the inert pair effect, +3 is more stable than +5 going downwards. Nitrogen shows a maximum covalency of 6, which is not, it's 4 actually that it can show. So D and E are the incorrect options. Can I check any option? D and E. There we go. We have come to DNF block, the next chapter of inorganic chemistry. Let's start with the very first question. Choose the correct options having all the element D10 configuration. Where can you find D10, 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 D10? Palladium, nickel, chromium. Can you? No. See, I can check it from chromium. This is what? 3d5, 4s1. So this is not showing, incorrect. Copper, 3d10, 4s1. Zinc, 3d10, 4s2. Cadmium, zinc, cadmium, mercury, they are belonging to the same one, no? So this is 4d10, 5s2. Silver is right next to the copper, so it will be 4d10, 5s1. All d10, I think B is the correct answer. Let's not waste the time, guys. Let's not waste the time. It's the most easy question right now we are having. And guys, you're welcome to ask me anything you want. The chat box or the comment section is highly open to everyone. And those who are watching this video right now, like it guys, like it, because I have come up with a very amazing idea of introducing the concept as well as the question that may appear in your exam in the similar or exactly the way they are right now over here on the screen. And one more thing I want to ask you is, be attentive guys. In our upcoming time, we will also launch our live sessions of solving the questions of JEE Main 2025, and that will be the mostly guessed questions. We have a team of Unacademy that works with the student, those who are right now coming out of their centers after giving the exam. They will be examining them, they will have an interview, and we'll get the guessed question, most guessed question, and we'll do the solution for that. We'll come up with the exact explanation of what question you have had in your exam. We have the next question, everyone. We have the next question. The next question simply says that the disproportionation reaction of MnO4 2- in acidic medium results in the formation of two manganese compound A and B. Let me just give you that. First of all, what medium is this? Acidic. Okay, I know what reaction they are talking about. MnO4 2-, this is called as potassium manganate. This potassium manganate under acidic condition gives you manganese dioxide plus manganese. Oh, well, this is not, yeah, this is disproportionation reaction. Mn2O KMnO4 minus, so this is permanganate. So how am I calling it as a disproportionation? Check out their oxidation state: +6, +4 and +7. Whenever the same element of the same compound or same molecule or same ion undergoes oxidation as well as reduction simultaneously, such type of reactions are called as disproportionation. What do you see? The correct answer? Okay, not the correct answer. The one which is with the smaller than A. Okay, oxidation state of B is smaller than A. So this means this is B and this is A. Then the spin-only magnetic moment for B. So mu for B is Mn plus 4. What is the configuration of Mn plus 4, guys? 3D argon, 4s0 and 3d3. So it will be like 3 unpaired electron. N is equals to 3. The mu will be under root of 3 into 3 plus 2 Bohr magneton, under root of 8 Bohr magneton. No, 3 into, what is it yaar? 15, root 15 Bohr magneton. Roughly like 3.9, then can be set up as 4 as a nearest integer. Can we see the answer 4? Why not, sir? Every time we do it correctly, and that's what our confidence is all about. We are now high on the confidence, and I want you people to high on the confidence as well. We have the one most very important chapter we have. This chapter is highly important for all of us. This is coordination compound. In 2024, in mains and advanced, both of point of view, this chapter had the most weightage among all the chapters from inorganic. So this chapter is your none other than coordination compound. The question is simple, that number of paramagnetic species from the following. So guys, see, I have plenty of ways to solve this question. You can try it by your own convenience, but I'll give the correct answer. I have to find out the number of paramagnetic. Nickel cyanide. Nickel is 3d8. In the presence of strong field ligand, this will be all paired up. Nickel tetracarbonyl, 3d8 4s2, all will be paired up. Nickel chloride 2 minus, 3d8 4s2. And this is a tetrahedral complex. How should I fill the electron? Number 1, 2, 3, 4. That's why it will make sp3. d8 will be filled. It has unpaired electron. I don't know how many. 1, 2, 3, 4, 5, 6, 7, 8. 2 unpaired electron it has. d8. Iron is 26. 26 in cyanide. 3d6 4s2. So 4s0. 1, 2, 3, 4, 5, 6. No unpaired electron. Copper in positive to oxidation state will definitely be having, because copper has a configuration of 4s2 3d9, so one unpaired electron will always be there. Iron in its positive 3 complex has unpaired electron, and yes, it will be paramagnetic. So then iron is in its d6 state. So d6 state, you can fill it like this. You remember everything, octahedral complex is there, and d6 configuration, how should we fill? 1, 2, 3, then it's a weak field ligand, then 4, 5, and then 6. So we have number of unpaired electrons are 5. This is also correct. So I think 1, 2, 3, 4. Correct answer should be, there we go, 4. So let's have a round of applause for all of us guys who are right now working very hard on this. And we will finish this entire huge paper. This is a 50 question paper that we have to finish in coming not more than 1 hour. I'll take literally half an hour from here and I'll finish this paper. We have next question. Total number of moles of AgCl which are precipitated on the addition of excess of AgNO3 to 1 mole of these compound. Guys, this will give you what? 1 Cl is there. This will give you 1 mole AgCl. This will give you 2 mole AgCl. This will give you 0 moles of AgCl, and this will also give you 2 moles of silver chloride. So what is the correct answer? 2 plus 2 plus 1, 5. Absolutely, sir. If you do it, you rock it, sir. I'm continuously watching your chats, but nobody's asked me anything, and that's why I'm not even responding you back on the chat box. Okay. We'll go to the next question from here. We'll go to the next question. The next question is from salt analysis. Salt analysis, we have plenty of questions came from salt analysis previously, but I think this is not a question of salt analysis. This is a question of crystal field theory, by the way. I think this sequence might have changed, but it's okay, no worries. We have a question saying that out of these all, we have to find out the correct order of wave number. Wave number, you know what wave number is? Wave number is 1 by lambda. So 1 by lambda, and it is directly proportional to the energy delta E, which is equals to hc by lambda. Getting me? So whatever the having is higher strong field ligand over here, and that will be possessing what? That's what we do. I don't know, man. Anyways, we'll do it. So here, so guys, if we talk about the strong field ligand with the same CO, we have cyanide more dominant than ammonia, and then water, and then chloride. This is the order we are following. So in this way, what we see is A, which is having the highest one. B will be having highest energy, followed by A, then followed by C. This is the order until like delta E order, which is actually delta O. Then what we talk about is copper, and its complex is square planar. Usually square planar have the highest one, but not sure. Okay, I'm not so sure. I will have to check, by the way. BCA, where can you find BAC? BAC. Oppositely, it will become what? CAB, cab. I can see the cab here. CAB. Not even here. I think C is the correct answer. And A is the correct answer. I think something is mistaken by us. Let us read the question properly first. The correct order of ABCD in terms of wave number of the light absorbed. So I think we have written it very correctly till here, that new bar is energy only. Highest energy is for cyanide complex, no doubt, and all of them are having the same oxidation state as well. This is positive 3 cobalt, this is cobalt positive 3, this is cobalt positive 3, and this one is copper for positive 2. So what's the answer they are showing is A. D, A, C, B, B, C, A. Cyanide complex must have the highest. B, then OMG, why? This simply showing to me that the order must follow B at the top of everything. Then we have this C, and then we have A, then BC is followed, guys. BCA, and man, why? So BCA is followed simply BCA. It's correct. Nowhere is BCA. BCA is not here. BCA is here, but D is coming at the end, but it must not, because seems like it's sp3. So I think this is also incorrect. Weak field ligand is also here. We have a weak field ligand, we have +2 oxidation. There are several reasons which are responsible for making it as less splitting. It has sp3 hybridization, it has less splitting, everyone. Anyways, now we have the another question, everyone. We got to match. Now starts your practical inorganic chemistry. Practical inorganic chemistry questions have been asked here. So let us match all of them. So what do I find? NH4Cl, NH4OH. Even I forgot it. Dilute HCl is the first. It is a group 1. Group 1 are the one whose chlorides are precipitate. Lead could come to this category. Pb2 plus comes to second and first both. Group 1 and group 2 both. Then hydroxides become their hydroxides even at less concentration are the precipitates, which is group 3, iron, aluminium. So I guess, and then all the carbonate will belong to the group 2, like magnesium, calcium, strontium. Aluminium must belong to the 1. Then manganese must go over there. Now I must check what we are doing right now. Is the correct answer A with 3, 4. So 3, 4, 1, 3, 4, 1, 2, 3, 4, 1, 2. A to 3, 4, 1, 2 at first only. Let me see. 3, 4, 1, 2. Guys, that's it. I can help you with. But if you face any kind of doubt in this segment of the entire inorganic chemistry, practical inorganic chemistry, I have a separate session taken only on this channel a few weeks back. You can search in our live segment as complete practical chemistry, sorry, it's practical in organic chemistry and practical organic chemistry, 2 segments have been taken. So this was the practical organic chemistry we had. The another question is, during the detection of an acidic radical present in a salt. Acidic radical means we are talking about anion. So a student gets a pale yellow precipitate. Okay, well, I already got an idea. Pale yellow is AgBr. So with difficulty in NH4OH solution, when sodium carbonate extract was first acidified with dilute HNO3 and then AgNO3 solution was added, this indicates the presence of what? Okay. Soluble with difficulty in NH4OH when the calcium carbonate extract was first acidified with NHNO3 and then AgNO3 solution was added. Anyways, I don't know about what they are talking about, but I know that AgBr is pale yellow in color when it is subjected to NH4OH. Ammonia starts making complex with silver. This type of complex is seen. Br comes out of it and then it becomes aqueous and that is start solving. So this was solid yellow PPT, pale yellow PPT, but now it start dissolving and that is the confirmatory test for AgBr. Anyways, coming to the next question. Next part, now only the part which is remaining for all of us is organic chemistry. Let's welcome organic chemistry. From here onwards we'll cover complete organic chemistry one by one. The way we start is from 11th standard GOC. The number one question from GOC that it came in my mind is the electronic effect. The most important part of this chapter is electronic effect. The very first question from electronic effect is saying that which of the following compound does not exhibit any resonance? Where can't you find the resonance? So this is oxygen here. So the resonance is only happening under here and not up to here because this is sp3 hybridized carbon. No sp3 hybridized comes under the part of resonating system. Then we have another. We have another question. Sorry, this is negatively charged species here. So double bond oxygen. Maybe it way does not exhibit resonance. So this double single lone pair, yes, it can undergo resonance. So yes. Here CuNH2. So this is how it look like. Yes, resonance. And then we have fourth. Guys, can you see this sp3 hybridized carbon? This makes this compound having no resonance. There is no resonance, there is no conjugated system, and that's why the correct answer is D. But still, I want to mention this part over here that this question is very important as the electronic concepts are highly important. We have here the application of electronic concept. Welcoming the applications of electronic concept, the question is simple, that says among which of the following resonance is stabilized by resonance? Carbocation is stabilized by resonance. Here, yes. Here, yes. Here, this is sp3, no. Here, I think there is no resonance as such because this is a doubly bonded carbon with positive charge. It could have been here. If the same could have been here, not like that, here it would have been, and then CH positive would have been there, then it must have gone for resonance, not here. This is correct. D is also incorrect. So correct answer I think must be what? A and B. A and B only. Whoo! Next is the total number of chiral compound can you see from this whole. So guys, this question I took it from GOC and the optical activity, which is your Stereoisomerism, one of the very important part of this chapter. So where can you find the chiral compound? Chiral compound must have what should I call it, chiral center. Sometimes chiral center could be your chiral carbon with 4 different groups, and sometimes it can be this kind of structure also with double bond and the one ring which is attached. These two are not in same plane and it has no element of symmetry. I have explained this part earlier also. This is having no element of symmetry, and even if it is not having any chiral carbon, this is also optically active. This is correct. This doesn't seem any chiral. Oh, K, is it chiral? Yes, it is chiral. This is also correct. There, plane of symmetry. There, plane of symmetry, meso, optically inactive. There, yes, plane of symmetry, meso. So these 3 are optically inactive. I think, let me check the answer first, and answer is 2. So I think I was right about first and second. All of the remaining 3 are non-achiral, or we can say asymmetric. No, they are symmetric. Now we'll move to the next question from here. Now next chapter is hydrocarbon. From 11th standard only, the next chapter is hydrocarbon. The hydrocarbon question is simple. Says that a compound A on reaction with X and Y produces same major product but different byproduct A and B. Oxidation of butter, I don't know what is it saying, but let us see. It's an alkene. What does this alkene give you? A double bond O. That means definitely this bond has gone for reductive rupture, reductive ozonolysis. So X could be what? Ozonolysis. Next is compound A. Oh my god, what is compound A and B then? X and Y respectively are, I don't know, because A and B are the same product, like in no. What do you see? A and B are the same product only, right? Okay, and we have to check the correct answers. Dilute KMnO4H positive and dilute KMnO4. Dilute KMnO4 gives you just OH only, so not a point of mentioning dilute. I think it should be reductive ozonolysis as well as KMnO4H plus. Because this has no further hydrogen to oxidize, even if it will also work. Like if I take concentrated KMnO4 under acidic conditions or basic, it will work. So I think D is the correct answer, guys. Thank you. Okay, now moving forward to the next question we have. Okay, let me know any doubt is there, but be active, guys, be active. The correct sequence which is used in converting 2-bromo-nitro ethyl benzene, 4-bromo 2-nitro ethyl benzene C2H5. This is what you have to form, and the preparation is taking place from benzene itself with a set of sequences of the reactions. First you will apply COCl, then it will give you COCH3. COCH3 with Br2, C double bond O is there, it will give you meta position. This is incorrect. We have COCH3, AlCl3, it will give you C double bond CH2. ZnHg will give you CH2H5 on there. Then Br2 will give you at para and ortho position, and HNO3 will replace the ortho part only. So I think this is correct. This reaction sequence is correct. Br2 LBl3 with first give you Br somewhere, which is ortho para product will come up in the COCl3, I guess. Then HNO3 and H2SO4 directly will do the nitration, and ZnHCl will reduce all the nitro product also. Incorrect. Nitro product will also be reduced to NH2 then, or NH2. This is also incorrect. Only correct answer is B. The next question we have, correct sequence of the reagents that are used in preparation of 4-bromo 2-nitrophenyl. Okay, this is the correct. It's already done. Haloalkane and haloarine, everybody. Haloalkane, haloarine, the first chapter from 12th standard of organic chemistry. Till now, we have finished the 11th standard chapters, which were GOC and hydrocarbon. Let us look at the question, guys. Let us look at this question. The question is pretty simple and very interesting also, that SN1 reaction is given by out of these compound in where? A, B, C, D, where can you find it? So what you think, by the way? Which you think? Or A, which bromine should give you the SN1? The one which can form the stable carbocation, which is a relatively stable carbocation, so it will give you B. Then I can find that over here a positive charge will be resonance stabilized. This is again, this will give you SN1. This gives you neither SN1 nor SN2, only this can give you. This can give you. And there, this 3 degree will give you. So the correct answer is A, B, A, B, A. Can you find B, somewhere? B, D. D is the correct. I don't know why D is not given, but D is the correct answer. Okay, D there is given. No, not that. This was the correct answer. Next question, the number of moles of AgCl. What do you think the number of moles of AgCl, everyone? Number of moles of AgCl formed from this reaction, which can undergo SN1 reaction. This AgNO3 is giving what? SN1 dilute. Anyways, this can give you 3 degree. This is reso stable. This is also reso stable 3 degree carbocation. This doesn't give any SN2 directly bonded. This will not give. I think the correct answer should be 2. 2 is correct. Alcohol phenol ether. Now we have come to alcohol phenol ether. I'll start with chemical reactions of alcohol phenol ether first. We have a question, everyone. Let us look at the question and please try to understand the question. It's a compound P that upon nitration gives dilute HNO3, which yields 2 isomer A and B. First of all, P compound we have to find out, which upon dilute HNO3 is giving you ortho and para products, which are, I know, understandable. Then we have these isomers can be separated by distillation. That means they are ortho para only. Isomer A and B show the intramolecular H bonding and intermolecular H bonding. That means ortho para only. Compound P on reaction with concentrated HNO3 yields a yellow color compound and what is zup 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 zup. So compound P should be what? What do you think? I think now I have got the compound. Compound P is this phenol. And compound P on reaction with dilute HNO3 gives you 2 products A and B, which are ortho and para. C substituted groups, ortho para nitro phenols. This is doing intermolecular, this is doing intramolecular H bonding. Then compound P on reaction with concentrated. If you make it reaction with concentrated HNO3, gives you an yield of compound C, which is a strong acid, not so strong, but yes, stronger in the terms of organic compounds, called as picric acid. Then, but it can give you bicarbonate test. Number of oxygen atom present in compound C. Number of oxygen atom, can you say 2 plus 1? 7 oxygen atoms. Can I see the correct answer? 7. 7 is correct, guys. The next question we have is from, okay, let me put the charger. Okay, man, it's my bad. I didn't switch on the plug. I just only plugged the charger and didn't switch it on. My bad. We have the next question, guys. So first we are reacting with dilute H2SO4. This must react and must form a positive charge here. This will go on attack. Then 1, 2, 3, 4, 5, 6 will be connected to the 6th carbon atom. This is how it will look like. The first carbon with a positive charge has shifted to the next carbon here. Sorry, that's how it look like. And what is this here? So 1, 2, 3. 3 has this group with us. Or I remember one of the question was there, and the reaction was very different there. Remove this first, make it. Will make it more stable resonating structure, which is like this. With the positive charge here, and which is a 3 degree now, 3 degree along with the resonance. Then on next step, this will attack this carbon. Let's say this is a negative charge, this is a positive charge. We'll have to check it. Kanan Sela, sir, please help me for your hard work. Thank you. Okay, don't worry, guys. I'll bring up pure JEE Mains plus advanced courses very soon. Until then, please allow me and let me think of the questions, guys. I have stuck it. What should I do, man? Sit back and relax and then think of it. What is it saying, by the way? Man, what should I do? Make it the first reaction. I can retry this question, but I would we are removing it. Okay, so now let us see. This is a minus charge, this is a minus charge of correct. So 6 member ring will be there, and those member are so this is 1, and there's a positive charge now. So 1, 2, 3, 4, 4 with 5 as a double bond, and then 4 also has a CS3 group. 4 also has a CS3 group. So that's how it look like. So now it's going fine, guys. Now it's going fine. It's the most stable possibility that we have made. So now simply water or any of the group may come attack on this hydrogen. See, so now it will go for 1,2 hydride shift. So this hydride shift is there, hydrogen goes there like this, and it will make some compound like this, plus charge is here, and then it will make you what? It is the correct answer. No idea on that, but it's okay. So we have got the correct answer as C here, and now we have aldehyde, ketone and carboxylic with us. Okay, so first question is the major product of the B formed in the following sequences is what? Following sequence is given to you like that. C2H5 MgBr is there. This cannot have any reaction, this can have the reaction. C25 Mg plus, this will come attack, and it will form a OH. Water will make it simply CH OH, and this has C2H5 also attached here, and then it has OMe. Then on HCl, now HCl will it's make it 3° carbocation, and then I think let me check the correct answers first. So there are like MEO, and one is there Cl. I think this is the correct answer. This will be eliminated out in form of water, and your correct answer will be this. Correct answer is this, B. So guys, if we talk about this particular chapter, which is aldehyde, ketone and carboxylic acid, most interesting part is its chemical reactions, and it is a vast chapter. I would like to basically advise you that make a short note in which all the reaction must be written. It has a largest number of reaction. Somewhere, for an example, if you talk about aldol condensation, Cannizzaro, then you require the mechanism also. You need to put the mechanism, and then you will be getting out the final answer. Somewhere wherever the shortcut is needed, I have shown so many shortcuts in this session of aldehyde, ketone, carboxylic. Please visit that chapter, and then you can basically become confident. Now we have another question that we have given up with this molecule which has no alpha hydrogen, no doubt. So this will give you The first will be the aldol condensation reaction. So guys, this is your OMe, and what was that reaction, by the way? The first attack takes place of nucleophile. Base will do, lighter will be oxidized because of the attack of OH minus, and it will make you OH, CH2OH plus HCO minus Na plus. This is the first product we will be getting. The next product will be, after taking is CH3, CH2, MgBr, NH, DMF. What does it do? Now, what is this CH3, CH2Br, NH is doing here? Anyways, after HI, so we'll be getting ra 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 ra, and this will also be like OH, and then I attacks here. This it will become CH3I plus OH. Ra 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 ra. We'll come to the next question from here, and I think D is the correct answer given. The molecule that gives you haloform test, one of the very important tests, and I'll star mark this question, I'll star mark it. Anything that has this group, methyl keto group, CH3 C double bond O group, give this reaction and forms CH3 is converted into CHCl3, and this C double bond O group will come CO minus, that means it is oxidized. This doesn't have any methyl keto group, this is having methyl keto. This doesn't have any methyl keto. This is something that can be oxidized to methyl keto. So this will become like this. This is again methyl keto. So this is also gives. There is no methyl keto, won't give. So how many are basically here with methyl keto? How many can you see as methyl keto? 3, I guess. 3. 3 is correct, guys. 3 is correct. 3. This, and this. Then we have amines. The next chapter, amines, everyone. We have the next chapter, amines. Amines is, so in amines, the number of compound that will give you a reaction with Hinsberg. You all know what is Hinsberg reagent? What is Hinsberg reagent? Benzene sulfonyl chloride that reacts with 1 degree amine as well as 2 degree amine. But 1 degree amine after reaction gives a product that also has an acidic hydrogen that further reacts with basic medium and gives you the soluble product. But 1 degree and 2 degree both gives you Hinsberg reagent test. So I'll write it 1 degree and 2 degree. So identify 1 degree and 2 degree amine, not amide, just amine. This is no amine, this is just diazonium, this is amide, no. This is 1 degree, correct. This is 3 degree, not correct. This is 2 degree, correct. This is 3 degree, not correct. This is 1 degree, correct. This is 2 degree, correct. This is no, this is basically pyridine, no, doesn't give. This is 1 degree, correct. This is amide, no. 1, 2, 3, 4, 5. 5 reagents are there which will give you, which are 1 degree and 2 degree amines, will give you the Hinsberg test positively. Correct answer should be what? 5. Now we have the next question. The number of isomeric aromatic amines which with molecular formula of C8H11N can give you will be synthesized by Gabriel thalamide. You all must know that what is Gabriel thalamide synthesis do? Gabriel thalamide synthesis only synthesizes synthesis of only 1 degree amines. It gives you synthesis of only 1 degree amine. Gabriel. So you need to make, can be synthesized from Gabriel amines, just form 1 degree amines only. So 1, 2, okay, it's a C8H11N. Let us find the degree of unsaturation. 8 plus 1 minus 11 by 2 minus, no, minus 11 by 2, 11 plus 1. Degree of unsaturation is 4. That means it's a single. Guys, there is a formula you all must know. This is carbon plus 1 minus hydrogen plus halogen minus nitrogen by 2. No oxygen, so nowhere. So this is the degree of unsaturation. Don't get confused. Degree 4 means there is one benzene ring. Benzene ring has 4 degree of unsaturation. It's simple CH2. Yeah, NH2 is there. And then simply what will be applied? A methyl group is there. No, C2. C8 is there, no? Man, can I see the options? No options isn't there. Direct answer is the N6. Number of isomers, okay? Let me just reconfirm what was that Gabriel thalamide, and it gives you this 1 degree amine is formed. Only 1 degree amine is formed. Okay, it can only produce you primary amines, not only primary, only 1 degree aliphatic amines. 1 degree aliphatic amines. So if it produces 1 degree aliphatic amine, then what I'll do? I'll make some of the compound which are having aliphatic only. So benzene, we have CH2 NH2 here, it's 1 degree. Then bring 1 CH3 here, 1 here, and 1 here. So this is how we get 3 compounds till now. What else could be there? Ah, this could be one. CH3 NH2, this is one. So if we make it, this is a star, this is optically active, this could also be the correct answer. So now you count 1, 2, 3, 4, deep 5 and 6. I think 6 is the correct answer. That's will get it. So guys, basics are very important. You all must be focused. Okay, thank you Vishal. Guys, I must agree and I must say that don't make me the god. The god itself is divinity. The god itself is enough. He who has created this world. We all must thank to the god that god is the one who provided you students a good teacher like me. So let me be a teacher itself. Do not make me the god. Thank you, by the way. Thank you Vishal. Then next is biomolecule. Everyone, we are right now finishing this entire session for the day. Biomolecule is one, and then we have practical organic chemistry. That's it, finishing of the day. Biomolecule, one question is, for given cyclic hemiacetal, the correct pyranose structure. I don't think that's require any further of work. It's already given up with the pyranose structure. And what is it, by the way? A glucose kind of structure, but it was right, left, right. Anyways, I can make it. So do one thing, guys. Make a pyranose structure. So what does a pyran look like? A pyran look like a hexagonal ring like this. Now wherever you find the left hand side situated OH group, that will come up at the top. This is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So how am I going to make? This is 1. So one carbon is having where? OH at the top, H at the down. This is 2, OH at the top, H at the down. This is 3, OH at the down. So guys, right goes down, left goes up, like that you have to work. This is called as the Haworth projection. So in Haworth projection, this is how we represent it in the cyclic way. So this is OH, this will become H. On the fifth, this is 3 carbon, this is 4th carbon, this is 5 carbon, this is 6th carbon is CH2OH, 6th itself with one connectivity with it and one hydrogen. This is also having, 4th one is having OH in left hand side, come up at top and like this. So I have made this Haworth projection of this cyclic pyranose structure. You can copy down this part. Okay. Sir, here dextroleo concept will be there. Yes, you are right, Mahim Shah, and that's why we took that one compound as 2 compounds, D plus L form. So can we see any correct answer here? Okay, we'll take this up, down, up, down, up. Wait, up, down, wrong. Up, down, up, right. Up, down, up, down, up. This is also right. Up, down, up, and CH2OH. Oh, these two are identical only, yaar. Oh, no, this is wrong. Oh, D is correct or what? Up, 3, 4. Let's say 4. What is it coming? 4 is coming at top. 4 is coming at top, guys. What's happening? I think we are right here. Up, down, up. This is correct. This is correct. This is right. This is wrong. About this. So D is correct. Fine. So that was a good question, by the way, we had. So the two important part of this particular chapter that we call as biomolecule are, one is carbohydrate, another one I guessed it. The one carbohydrate question has already given to you. The another question comes from the amino acid and protein. So in amino acid, you must have the idea of what all amino acids are. So there is a tetrapeptide which we are going to make tetrapeptide, and in this tetrapeptide it is asked that how many, I don't know what is it asking. The negative charges will be how many in this tetrapeptide. So we have glycine is thus glycine connected to glutamic acid, aspartic acid, tyrosine. Honestly speaking, guys, I have forgot their structures as of now, but don't worry, we have the solution here with us. This is your glycine. This is the actual compound you right now having, the one compound that was given, and at this in basic conditions whatever, but I could have guessed that question rather than going for the structure. I could have guessed the question. So if I guess about it, that already see how can I solve this question. Glycine has one COH, one of the COH of glycine, or let's say NH2 is matched with the glutamic acid of COH. One COH is still remaining, one COH is still remaining here. Tyrosine has one COH which is left because its NH2 part has been connected. One COH, two COH, three COH are remaining. One COH from glycinate ion we have. So what we can see is, so one COH, two COH, three, and the last will also be having three COH. So how many CO minus charge we are getting? Where is the answer, man? Check it out, guys. Check it out. I think 4 is the correct answer, because even this phenol group have a negative charge. This phenolic group will also have a negative charge. The correct answer is 4. And now I'm feeling pretty much tired. Thank you for your support. Thank you for your love. And now we have the next question, practical organic chemistry. So when we do the analytical chemistry test, this question is very easy, by the way. Nitrogen. I remember in nitrogen, first of all, we make the lazinase extract called as sodium extract, and that is NaCN along with carbon and nitrogen, and then its compound with iron makes a complex like a Prussian blue. So this is your Prussian blue, by the way. So the first is matching with third. Sulfur. What does sulfur make? I remember sulfur used to make where is sulfur, by the way, yaar? Sulfur is not even here, and sulfur is here. So this compound, when corrected with like if any sulfur is there in any form, by the way, sulfide ion is there, then this form a complex like this NOS, and that's a PPT, by the way. So that gives you a violet color, I guess. So the correct answer is this. Phosphorus reacts with this ammonium molybdate forming ammonium phosphomolybdate, and reacts with silver nitrate giving you silver halide as a precipitate. Now the correct answer should be A to 4, A to 4, B to 1, A to 4, B to 1. No, yaar. A is going to 3, by the way. A is 3, B 1, C 4. This is correct, A. So guys, those whoever are facing any kind of problem, if anyone faces any kind of problem, believe me guys, I have already covered these sessions in very detail. Some of the sessions on practical organic chemistry plus practical inorganic chemistry, 2 sessions consecutively have been taken by me. You can go to our live session on the channel you right now are watching me. Go to the live session, just simply find practical organic chemistry. Practical organic chemistry will get all the basically sessions on it, and you can prepare yourself, make the short notes out of it. Then next we have, सर और कितनी देर का लेक्चर बाकी है दोस्तों? वी आर राइट नाउ कवरिंग द फाइनल लेक्चर, फाइनल बेसिकली चैप्टर ऑफ द इंटायर केमिस्ट्री. सो यू मस्ट बी अमेज्ड बाय द completion of the organic chemistry we are right now having. And believe me, this is not even a chapter which right now we are having. This is something which I added from my behalf so as to complete the complete syllabus of JEE Main 2025. Let us come back to the next question. The A is correct answer over here. So guys, are you guys ready for the final question of the day, everyone? Let's see who can solve this final question. We have the final question of the day. In Dumas method of estimation of nitrogen, 0.1840 gram of an organic compound gave 30 ml of nitrogen, and it was collected at 287 Kelvin temperature, 758 mm of Hg pressure was there. Percentage composition nitrogen been asked. So guys, probably by 9:30 I'll be getting free. This is the last question, as I told you, and let me check if any further question. Okay, further question is there? No, we do not have any further question. So probably the last question. Let me solve the question for every one of you, and please try this question along with me, because don't let your teacher do all the hard work. You should also engage yourself in doing the hard work with your teacher. So I would like to give you one simplest way to solve this question. My simplest way says that whenever you are given with the pressure of nitrogen gas, we have 758 mm of Hg. You can divide it by 760 and then it becomes what? atm. Then we have volume of nitrogen that I'll find out. Okay, we will find out the volume, which is also given to us 30 milliliter. So we have PV equals to an RT. I'll apply that PV equals to an RT. And temperature is already given to me, how much? 287 Kelvin. And number of moles of nitrogen are unknown to us. That is what we have to find out. How can we find out the number of moles of nitrogen? So nitrogen moles are PV equals to an RT. So PV upon RT. How much is pressure? 1 atm almost. 1 atm. Volume 30 ml into 10 to the power minus 3. It has come in liters now. How many moles of temperature? R is 1 by 12. Usually we take under atm and volume in milliliter. We can also write in 30 to the power minus 3 liters. Temperature is already 287. Just solve this and you will get your number of moles of nitrogen. N2. This is the number of moles of N2. So how much is it coming, by the way? So should I solve this? So this is 124. So this is like 30 by 24 into 10 to the power minus 3. And I must say it 5 by 4 into 10 to the power minus 3 moles of nitrogen N2. Percentage of nitrogen, how can you find out? Mass of nitrogen N2 or N, whatever it is there, upon mass of the organic compound multiplied by 100. How much is the mass of organic compound given to us? The mass given is 0.1840. Do one thing, mass of nitrogen you already know, which is like moles into molar mass. So moles are 5 by 4. 5 by 4 into 10 to the power minus 3 multiplied by 28 is the mass of nitrogen N2 divided by the mass of organic compound 0.1840 into 100. Please solve this calculation and get your answer, everyone. But again, don't try to be very smart and do not apply too many of the approximations. If you apply approximation, your answer may vary from the fixed number that is appearing over here, which is 19%. But I don't think it will vary a lot. I personally think this will come up as 19%. So thank you for your sessions. Thank you for your patience. Thank you for supporting us, everyone. Spread this lecture to your friends, as many as possible, and give us this kind of support. Will keep us boosting for our next time, and whenever we'll come up the next time, we'll also bring very good sessions on for 2026 and 2027 and onwards. So guys, we have a very big platform for all of you to give your test upon. This is going to happen on 19th of January 2025. Please go and give this All India mock test for IITJ 2025, and the best set of faculties have made this paper. We have all contributed in the preparation. You will be getting very good questions right there to practice about. You will also get an idea, basically a simulation. You will feel that the examination mode you will feel, by the way, that is also one of the confidence you'll give. And also you can find your All India rank by going on this All India rank AR rank predictor. That both of the links are given in our description. But do one thing on priority, that if you haven't subscribed to us, do subscribe us and let your every friend know that we right now are providing every content of JEE Main and Advanced in English. Also scan this and be our part of this Unacademy Ranker Reward program, where if you score well in your upcoming the upcoming exam of JEE Main first attempt, then we can reward you with this very beautiful presentations. So that's it, guys. That's it. Now I should take a leave. I know that sir forgot there is attempt 2. I know, man, there is attempt 2 as well. And what should I say now? Thank you guys. Thank you. Bye bye. Now I'll come up and join you shortly. Bye bye everyone. Take care.
तुम जो हो इस पल मेरे हो, कल शायद ये आलम न रहे, कुछ ऐसा हो तुम ना रहो, कुछ